statement. When you use it down inside a rule inside the prelude, which is, the rule prelude is where variable declarations happen. Okay, so in this case, what we're saying is, we're declaring this data source called foo, and we're going to create a variable bar, and bar is going to get the data from the data source foo with a query parameter, q, equal to whatever the value of the variable ISBN is. Make sense? That hash there, name value pair, if we had multiple name value pairs in that hash, this would construct a query string and append it to that data source URL up there. And it tries to be intelligent that if the data source already has a question, the data source URL already has a question mark in it, it'll just append it with ampersands. If it doesn't, it'll put the question mark on for you. So it essentially does the construction for you of that URL. If you don't like that or it doesn't quite work, you can also just create a string. And if you pass in a string instead of a hash, it'll just tack the string on exactly as you put it in here and then make the query. Now, because this is a data source, every query is potentially different. So in this example, for example, ISBN, we might be getting that out of the URL of the page that the user's on. And so we're going to make a query for ISBN 5 and a query for ISBN 6 and a query for ISBN 7. We cache each of those separately. So they're cached according to the complete URL of the query. So if somebody's going through and getting a different ISBN every time, obviously we're going to be making a data query each time. But once they have that, if it goes back again, then we don't re-query, we cache that. Does that make sense? So let me show you an example. If I can figure out how to make the mouse move. You knew I'd find a way to get Emacs into the presentation.
I thought you gave up on Emacs yesterday.
Are you kidding me?
He's going to build his own.
I'm gonna make sure that there is something to do with Emacs at my funeral. So here's a more complete example. That's a similar. This is actually a slightly simplified version of the rule set, which does the library lookup demo that I did in my talk earlier this morning. Okay. So we have a data source called library search. We're grabbing it. And then inside the rule, notice, I don't have a pointer, but notice inside the regular expression up here, we have the /d plus in parentheses. Inside regular expressions, that says capture. That's essentially capturing the ISBN out of the Amazon URL and setting ISBN over there. And then down here, book data is declared to be a data source which gets from library search with Q equal ISBN. So essentially, that's what I'm talking about. We're getting the ISBN out of the URL and then using it in a query. I won't go over the rest of that yet because we've got a few more things to talk about first before we get there. Okay. So switching gears slightly, another way to talk about or to use data inside KRL is what we call intrinsics. Intrinsics are essentially the built-in data sets which are available inside KRL. So they include things that we are gathering from the browser, like the IP address and the domain name of the page, and then things that we call them second order context, where we're taking the IP address and turning it into a location, and then taking the location and figuring out the weather. Right? Sam demonstrated some of this. And so I don't need to go into great detail because Sam did show some of it. But for example, in the rule prelude, you can say C is equal to the country where the user is. And I should mention that since this is GeoIP, by the way, we call this stuff that we're computing ambient context. We call the stuff that the user is actually supplying to us in a card or something else active context. So those are the words we use to describe these. So this is an example of ambient context. We're getting the country. For GeoIP, the numbers roughly break down like this. If you ask for the country, it's 99% accurate. If you ask for a state, it's about 90% accurate. If you ask for a city, it's about 80% accurate. And if you ask for a zip code, you're probably somewhere down around 60%. Okay? Because of things like, proxies and other things.
And countries with no zip codes.
Yeah, countries, well, they all have some kind of postal code. And if you look at the documentation, actually it's for postal code and region, not state. But, you gave Craig something to say. Okay, so the next one, we're getting the current temperature from the weather, and that's always the current temperature of the user calling the rule right now. That's not the current temperature of the server. That wouldn't be very accurate. Okay? So we're going out to Yahoo Weather in this case, and we're grabbing that data, we're parsing it, and giving you back the current temperature. And finally, in the case of some things like that, you can just grab the domain from the page URL if you want that, if that's interesting to you.
Phil,
Yeah.
on domain, is that, what do you declare as domain? How many segments? Is
Domain's
that,
the whole thing.
It's the whole thing, so it's
Yeah.
more the host name.
Well, no, I'm sorry. Host name is the whole thing. Domain is the last two. TLD is the last one.
Okay.
That's the way the documentation has it, and I think that's the way it actually works. So.
Wouldn't it be cool if there's Kynetx data intrinsic?
Repeat the question.
If what? Repeat the question?
Wouldn't it be cool if there was intrinsics in KRL for Kynetx data or for Axiom data?
It would be. Wouldn't it be interesting if there was intrinsics in KRL for lots of data, right? And there's lots of interesting data out there, and Tim's going to talk about some of that stuff tomorrow. We don't want to steal his thunder. We've already been down that road, remember? So, Sam showed you this one, right? If we can. I mean, again, this is just showing you that there are predicates on some of that calculated context. Now, I showed you earlier that we could grab data, but the question is, how do we use it? We have an operator called pick. And what pick allows you to do is pick out pieces of a large data set for use. The thing in the string right there, the $.docs, looks like some sort of weird code language. It is. It's called JSON path. If you're familiar with XPath, JSON path is like XPath for JSON data. We don't, at present, have XPath integrated into the system. So pick only works for JSON right now. As soon as I have a use case, I'm going to have to build it. So I'm kind of building as people ask for things. So somebody is going to come to me and say, hey, I've got this great XML data set, and we will deploy XPath either then or before. So if you got the need, let me know, and we'll get it out. So what this is saying is this is grabbing the books, like I showed you before, from the data source, right? And then we're picking out, dollars is the root of the JSON document. Dot just says, cruise down the JSON document as deeply as you need to until you find something called docs. The array thing is kind of obvious. Get the first one and get its URL. Get the element called URL inside that. And same thing, we're getting the title. So we're grabbing the title and the URL out of that. And that's exactly how the library lookup example I showed you earlier works. It grabs data just like this from a queryable data source that's queryable by ISBN, and then it uses pick to grab out the URL and the title using this XPath stuff, or the JSON path stuff, which, by the way, is in the documentation. And then these are available. Now, I wanted to show you, let me show you this too. And of course, you can use these things as expressions anywhere, right? So you can use them inside a predicate, for example, to check this. So I wanted to show you in this example I had over here, something else, which I didn't put in the slide. And Sam mentioned these extended quotes, right? The less than, and the greater than things. We call those extended quotes or here docs, right? Sometimes they're called here docs. A pointer.
Middle button.
Middle button. Hey, nice. Thank you. Don't look at pointer with remaining eye. Um,